Okay, this is the second video I'm making about polyethylene oxide, and the polymer is a semi-crystalline polymer in solid form and has unique properties. And being a member of the polyepoxide, it's soluble in aqueous and organic solvents and has the most unique intriguing properties. Since polyethylene oxide is a water-soluble polymer, I checked solubility in most common colorants that used in water-based paint application, mostly in ethers that used in that type of application doesn't solubilize. DPM, PNB, you think that like polymer will solubilize in like solvent. It doesn't solubilize in glycol. Ethylene, most common used ethylene glycol, propylene glycol. People think that solubility seems such an easy concept that you add a solute to a solvent and give it a stir or it will dissolve. But in reality it's not so easy. It's not gonna happen so fast, but this concept can help dissolve polymer in water, such like ethylene glycol mixed slurry, and adding it to the water create aqueous solution of the polymer. These particles in the ethylene glycol separates will much easier to water get to the polymer because ethylene glycol is miscible in the water. This concept can be used in different type of applications. Solubilizing polymer in water using such a carrier helps reduce mixing time and will help to ease the process of the making polymer solution. The polymer doesn't solubilize in THF, but the THF used in many applications, but it's miscible with water, and when you add water like 1:1 ratio in this case will create this clear thick solution. So another case is hydrocarbons. These solvents that which PEO doesn't solubilize at any temperature. I check VMP, mineral spirit, turpentine, and it will not solubilize in solvents like hexane, pentane, or heptane. It will not solubilize in acetates like in butyl acetate, ethyl acetate. But PEO has unique properties that in the room temperature it will not solubilize like in solvents like ketones like MAK, acetone, and xylene, toluene, alcohols like methanol, ethanol, propanol, butanol. But if you warm it up, solvent up to like 60 degrees, depending on the solvent, from 32 up to 60 degrees, polymer eventually will solubilize in the solvent. So I came across one article where study shows solubility of PEO, low molecular weight in ethanol, and what they see is after warming up it will create clear solution, but when you dissolve it and cool it down, they receive white cloudy solution, had this effect of thickening. But in my case, maybe because I used different molecular weight polymer, my sample didn't become cloudy, but the other solvent like butanol actually became cloudy. But after warming up like up to 50-60 degrees Celsius, it just became clear viscous solution, same as a stone. And for this toluene, after cooling down it gelled. This is another example. Butanol, same, after cooling down became cloudy and some particles separated from the solution, creating like clogs in the solvent. In the article what I read, they were mixing it under certain conditions, and here I just dump it to the solvent using just a handshake, trying to dissolve, see if it dissolves in the solution. Maybe if you have a controlled environment, you can create this clear solution. Other solvent that PEO dissolves pretty quickly, even without any force. It's a methylene chloride used in various applications, such as paint stripper, where you apply solvent to the surface. PEO has another ability to dissolve in acid solutions, such as hydrochloric acid and acetic acid and sulfuric acid. This is a diluted version of acids. PEO pretty much dissolve completely in the acid. In opposite situation, it didn't dissolve in aqueous solution of sodium hydroxide, and apparently even adding sodium hydroxide solution to the already made polymer solution create this cloudiness and separated polymer. Same thing happened in ethanol amine solution, where pH is very high, and triethanol amine solution did same thing. The particles are dispersed in the aqueous solution. They didn't dissolve properly. So this is it for now, and if you have any questions, just let me know, send the email or something, and thanks for watching. Bye bye.